Imagine a tremendous gathering, played by a perpetual number of stars. Planets and moons all performing together superbly. In any case, there is a single distinct fragment of this ensemble that has shocked space specialists for an extremely important time frame: exoplanets. Exoplanets are ordinary planets that exist outside our planetary system. Hidden somewhere below in the Milky Way, you might be surprised to find that among the gigantic number of exoplanets are objects in the galaxy so similar to Earth in a tantalizing way that they may be our divine twin. We enter the charming space of Proxima B, found just 4.2 light-years away. The James Webb Space Telescope is transforming our journey for a comprehension of these heavenly secrets. Imagine for a moment your mind journeying across the vast expanse of our reality, the Milky Way, which is home to more than a quadrillion exoplanets. That is a number that needs 15 zeros. If the size of an exoplanet were a grain of sand, we wouldn't simply fill the Grand Canyon. We would have enough to make Grand Canyon 2.0, spanning a significant distance. It is surprising that around 20% of these glorious bodies have been deemed Earth-like in relation to geology and atmospheric structure. That means 1 in every 5 could parallel our planet, and the narrative doesn't end there. Along with these planets, there could be another quadrillion moons-rough satellites like our own trapped in a gravitational dance with their parent planets. If you were to contemplate finding another body in space that harbors life, the universe provides a flood of opportunities. Now that we have expanded out the material of unimaginable scale, it's time to introduce the master craftsman, ready to paint intricate details. The James Webb Space Telescope. This heavenly Sherlock Holmes, with its heightened central focus and customizable optics, surpasses even the most advanced instruments. We're not discussing a small lens. It measures 6.5 meters in its primary mirror, with 2.7 times more surface than Hubble's. This allows it to separate the finest details even in the tiniest fires billions of light years away. Then investigate the particulars of orbiting planets. What makes the James Webb revolutionary is not only its seeing power, but also its highly advanced technology, such as cutting-edge sensors and spectrographs. These tools do more than simply observe. They analyze and interpret the remarkable light signatures emitted or reflected by celestial objects to determine their atmospheric composition, density, and even mass. Acting as a cosmic detective web, can identify whether a planet has water, organic compounds, or even oxygen. This elevates it from a straightforward observer to a scientific genius. It's not just an advance over its predecessor, it's a quantum leap. If you were impressed by Hubble's revelations, be ready for a genuine celebration of radiant discoveries. Now, let's focus on a single star in the divine shoe in particular. Proxima B, since its discovery in 2016. This puzzling planet has established itself as a Shakespearean legend, full of unpredictability and problems, astonishing stargazers and anthropologists alike. First of all, Proxima B is practically in our galactic neighborhood, just 4.2 light-years from Earth. To put that in context, if you could travel at the speed of light, you would arrive in under 4 years, about the same amount of time it takes your favorite program to air reruns. Why is this so important? In a universe spanning 93 billion light-years, finding a planet so close in, so promising is like finding a gem in a pile the size of Mount Everest. A treasure that may hold secrets about existence itself. In the grand tapestry of the cosmos, Proxima B is a golden thread, offering significant hints that could redefine our understanding of habitability and life beyond. Earth. It's not just Proxima B's proximity that excites scientists, it's the captivating signs that this planet may be more than Earth-like. It could be Earth 2.0. Proxima B sits in what astronomers call the habitable zone of its parent star, where conditions are just right for liquid water to exist. Imagine waterfalls, meandering streams, vast lakes, and perhaps oceans, as deep and mysterious as the Mariana Trench. But before we dream about visiting, we must consider its unique characteristics. A single day on Proxima B lasts 11 Earth days. First light unfolds slowly, refusing to yield to afternoon, and sunsets linger endlessly, producing long golden daylight. Idyllic, perhaps, but this has important consequences for climate and habitability. How would human biorhythms adapt? Would we eat 3 or 4 times as much in a single day? Would we sleep the same way? Life patterns might be tantalizingly similar, yet frustratingly peculiar. Cosmic riddle testing our understanding of what makes a planet habitable. How do we gather accurate data about a world we've never visited? The James Webb Space Telescope demonstrates all its capabilities as a giant Swiss Army knife. It's more than just a telescope, it's a laboratory in space. Thanks to its location beyond Earth's atmosphere. Webb can use advanced spectrographs to analyze the light from distant planets. Each element or compound in an atmosphere either absorbs or emits light at a specific frequency. By studying these patterns, researchers can conduct celestial biopsies, determining atmospheric density, pressure, and the potential presence of compounds essential for life like water, organic carbon molecules, and oxygen. Space science isn't just cosmology, it's forensic science on a cosmic scale. We don't wait for clues. We hunt them down, exploring the atoms and molecules that make up alien worlds. Webb turns our theories into testable facts, changing how we understand what might exist beyond our pale blue dot, just when scientists thought they had mapped the most. Fascinating details of this galactic structure, the story took an unexpected turn. Using Webb, astronomers detected a strange, complex electromagnetic signal from Proxima B, potential tech signature. It was so intricate in design that it hinted at the presence of a sophisticated civilization. The news spread through academic halls and across social media like wildfire. Could this be proof that we are not alone in the universe? And then, just as suddenly, the signal vanished. It never repeated, leaving behind not only a haunting silence, but also a maze of unanswered questions. Was it a transient cosmic anomaly? A random alignment of signals? Or something deliberate, a secret message? An indication of alien intelligence? The disappearance cast a shadow over Proxima B's mystery, igniting fierce debate and speculation. Was it just a passing oddity, or part of a much bigger, more complex story than we can comprehend? Imagine. But hold on, the cosmic tale is far from over. The ink has not yet dried on this chapter of discovery. Not yet dried, and there are still new chapters. This time, it is written by more than traditional experts, Harvard researchers at the forefront of a shift in perspective. As we move forward with the search for life on other planets, they are not satisfied with just studying the signals and the anomalies we've talked about so far. By changing the approach, they're raising the bar, turning the James Webb Space Telescope into a kind of colossal night vision telescope. They plan to look for sources of artificial light in both bright and dark regions of distant worlds. We're looking at incredible possibilities, like the chance of detecting artificial versions of dark cities that glow like brilliant SPS. Just imagine it might be a city with low emissions, humming with the presence of an advanced human civilization, transmitting its glow into the vast oceans of space as we continue to unravel the secrets of the universe. The search for alien life takes on aspects that go beyond the immediate interest in Proxima B. Our ultimate goal explores more deeply the vast new areas of space. This goal is motivated by both advances in technology and a significant desire to understand our place in the universe. Advances in cosmology and space exploration have led to the discovery of numerous exoplanets with potential habitability. Instruments, like the biosignature detecting tools of the James Webb Space Telescope, along with ground-based observatories, have expanded our ability to detect and study these distant worlds. One particularly fascinating area of study is the search for biosignatures, signs of life, These could include atmospheric gases like carbon dioxide and methane, which, under the right conditions, may suggest biological processes. The JWST's capabilities extend beyond basic discovery. Its advanced instruments can measure the atmospheric composition of exoplanets, helping researchers identify potential habitable worlds. The data collected could reveal intricate processes and dynamics of distant planets, offering new insights into their environments. As we investigate, efforts to study Proxima B continuously remain a key subject of inquiry, guiding us toward the space exploration of the future and the discovery of extraterrestrial life. As the James Webb Space Telescope expands our understanding of distant planets, the pursuit of life beyond Earth has become a major focus of research. The technology and methods we use, such as measuring atmospheric composition, can provide the most direct evidence yet of whether these worlds could support life. This quest is about more than just looking for familiar, Earth-like environments. It also involves considering a wide range of conditions that may facilitate the growth of life. Unexpectedly, the concept of discovering extraterrestrial life, or even the simplest signs of it, carries significant challenges. It impacts humanity's view of itself as unique in the universe, advancing our comprehension of life's possibilities. Imagine discovering that life has evolved elsewhere in conditions vastly different from Earth's. Could life on other planets have adapted to toxic atmospheres, extreme temperatures, or a lack of water? Could it survive in environments we previously imagined to be inhospitable? These questions push the boundaries of philosophy, biology, and cosmology. The potential habitability of Proxima B is a beacon in this quest. Though its conditions may differ greatly from Earth's, it represents a prime candidate for study. Even if no life exists there, the possibility of habitability opens the door to exploring other star systems that could support life. As we gather data from this distant exoplanet, we also learn about the broader universe, proving our instruments and methods for locating life throughout the cosmos. One of the most exciting prospects is the possibility of locating biosignatures or technosignatures, indicators that life might exist now, or that a sophisticated civilization could be present. While researchers remain cautious about interpreting abnormal signals, the search for artificial light on Proxima B or other technological signs could transform our thinking about extraterrestrial intelligence. If we were able to locate cities or infrastructure on distant planets, it would open up entirely new areas of inquiry, combining astronomy with the search for civilizations beyond our own. This dynamic, ever-evolving exploration is driven by multidisciplinary cooperation fields like biology, astronomy, engineering, and artificial intelligence. AI continues to improve our ability to scan the cosmos with ever greater precision. Already, new missions are being planned to take advantage of the Webb telescope's capabilities, with upcoming projects focused on stars and exoplanets even farther away. What implications does this have for the future of space exploration? As we expand our horizons into the universe, we are confronted by the thrilling possibility of exploring a cosmic ecosystem connected and overflowing with potential for life. Every new discovery, whether it's an atmosphere around a distant planet or a peculiar signal from a star system, moves us closer to understanding our place in the vast cosmos. But with every answer come new questions, challenging our most fundamental beliefs about life, the universe, and everything in between. The search for life beyond Earth is not just about discovering something familiar. It's about embracing the unknown, pushing the boundaries of our imagination, and acknowledging that we are part of a larger, mysterious universe. The future of space exploration is unfolding now, filled to the brim with opportunities to rethink everything we know about life and the universe. As we move forward, the discovery of another Earth or signals from an alien civilization may not be the end of the story, but the beginning of an entirely new chapter.